So let's see another more realistic example, and we're gonna parse data directly from a website. Let me tell you here, this is just for educational purposes. You always need to understand if the data is public, so you can actually parse it. Again, for Wikipedia, at least what I do, the content is Creative Commons, so you can get a hand on it. What we want to show you here is that a very complicated table that has multiple headers, etc. So that's why we're using this example. So we're gonna get the URL and we're gonna directly do NBA tables equals read HTML. The only table in this page is this one, the large one. So that works. And now we're gonna get NBA. It's gonna be that, and we see that all the players in this case have been parsed. What about something else? Let's actually open this page right here, the Wikipedia for The Simpsons, and here we will probably find several tables. Let's see, we have one right here, this one. There you go. So I'm gonna import it. We have 27 tables. Again, you don't see it. You don't see them, sorry, but they are there. And the most important one is the one we care, is this one right here. So the problem you're going to have with this table is that it's using both column spans and row spans. So in this case, this column here spans for 1, 2, 3 columns, and this row here spans for 1, 2, 3, at least 3 rows. So that column spans results in this very ugly data frame, and you will need a little bit of extra cleaning. So the problem you're gonna find with HTML tables that usually there are things that are not well formatted for machines. They are formatted for humans. So for example, in this case, we have this header repeated. When you parse this data, you're gonna find that every 20 rows, there is gonna be a header row, and you will have to clean it. For, in this case, 20 rows, you will need to drop it. You will do something like df.drop. Let's see actually if we can see it. I haven't tried this, but let's just do it live. .head, and they're gonna find 25 records now. So here, record 22, we find that header. So what we're gonna do is you will need to do something like df.drop, range 22, starting in 22 up to df.shape 0, right? These many rows plus 1, and every 20 rows. I don't know if this is gonna work. Let's just run it. Oh, it didn't even work. It didn't compile. There you go. Oh, this is NBA actually. There you go. So maybe it worked, you can check it, but what I'm gonna say is, again, there is some cleaning to do because HTML pages are optimized for humans, not for machines. So usually it's gonna take a little bit more time. The good news is that there is usually a service associated that you can consult. So for example, there is a Wikipedia API that you can use instead of a page. But again, sometimes it's just easier to pull the data directly from Wikipedia. So that's it. You can also write data to CSVs, or of course, or HTMLs. That's pretty much the standard, as we've said. This is all we had for the read data portion, and we're gonna move forward now with a few other methods, especially what we call data wrangling. We're gonna do a little bit of grouping and keep moving forward with our tutorial. We have decided kind of last minute to add a final source of external data that it's going to be an Excel file. It's just a common Excel file as you know it, because we imagine that you might come from an Excel background, so you can just export the data you have in your Excel files, spreadsheets, and load them into Jupyter Notebook and start working with them with Pandas so you can try things out and kind of draw the parallelism between Excel and what you do with Pandas and Python. So the first thing is that an Excel file is not a text file. So if you try getting the content of it, it's not a text file. It's not so simple to parse it. So that's why it's going to require external tools that they are already installed in Notebooks AI. They might be easy to install in Golab, but it depends on your computer how you're going to install it. So just keep in mind that there might be issues when importing data from Excel if there is low compatibility between the library you're using and the spreadsheet version you're using. But without getting into those details, there is this read Excel method, which pretty much takes care of everything for you. Has different parameters like defining the sheet that you're reading from, of course the path, etc. So we're going to start reading this file, which is products file that has 3 sheets: products, descriptions, and merchants. And it's actually something we use in an Excel file in our data analysis from Excel to Pandas course to show how to merge data and all that. And from this file, what we're going to do is just read Excel. And what you're going to see is that it reads the first sheet of the Excel file. I mean, a data frame just corresponds to one sheet only, right? And the first one is products. So that's what we are reading. There are different behaviors for it. You can change the way you parse headers, etc. You know it already. Defining a specific index. That's pretty much everything we have seen so far. Selecting specific sheets is simple. Just pass the sheet name, and you can read either products, merchants, whatever sheet is available in the current Excel file. There is another format or a specific class that it's a little bit more advanced, that it's the Excel file class. So it's not, as we were doing here, read Excel directly is going to read that Excel file into a data frame, but you're going to instantiate this Excel file class with the parameter being the file name. And now these files going to have just a reference of everything you have. In this case, we can do, for example, sheet names. It's going to tell you have products, descriptions, and merchants. This is a little bit more of a explanatory data analysis. So let's say you can't use Excel to actually see the contents of the Excel file. This is going to be helpful. You're going to first parse the Excel file, get the sheet names, and a little bit more of an understanding of it. And now we can say from this file we have previously parsed, it's right here, or instantiated, we can parse the products sheet, and that's going to get you that data frame. And the same thing is going to happen with all the parameters we can pass. They are the same as read Excel. Finally, you can see that there is also a to_Excel file, and it works pretty much in the same way as to_CSV. You can decide if you pass an index or not, and also you can define if you're going to pass a sheet name or not, or it's just going to be the default one. So as you can see, getting your data into from an Excel file into a CSV data frame, is extremely simple. There are more customizations to do. Let's say all your file is shifted, right? Either rows or columns. You can change that with star row or star column. That's going to work too. So that's pretty much the only thing we need. If your writing process is a little bit more complicated, like for example, you want to write specific sheets in a multi-sheet Excel file, you can use what we call an Excel writer, and it's also part of Pandas. So you instantiate the writer, and then you can start the write process, saying which sheets you want to write with each one of those data frames. So again, reading and writing data from and to Excel files is relatively simple. It all depends on the libraries that are installed. It depends on what libraries you have in your current environment, if it's Windows or if it's a Linux / Mac. The documentation of pd.read Excel might have more details for the given platform that you have. So let's see if it names per document. If it's not here, it's going to be in the Pandas documentation. But there might be requirements for each one of the platforms that Pandas is supported. So just check it out. Check for your own platform. If you're in Windows, Mac, Linux, how to get those libraries installed.